All right, today we're jumping into something really cool. It's a new paper that's exploring a pretty radical idea. What if an AI could actually learn to teach itself? Let's get into it.
I mean, this is the big one, isn't it? It's the question that's driving pretty much everyone in the AI field. We've built these incredibly powerful models, but figuring out how to get them to that next level, well, that's a huge challenge. And it turns out, the way we've been doing it up until now is really starting to hit a wall.
So here's the thing you have to understand. For an AI to learn anything, it needs data. And not just a little bit, it needs mountains of it. For years, that's meant feeding it these massive libraries of text and code that have all been collected and organized by people. But that whole approach is getting tricky. It's super expensive, it's slow, and we might actually be running out of high-quality human data to even give it. This is the big roadblock.
And that's exactly where this new research comes in. Just imagine for a second, instead of us having to create the curriculum, what if the AI could just create its own? Like it could come up with its own challenging problems, try to solve them, and then turn around and grade its own work. That is the breakthrough idea here, a system where an AI improves all by itself.
Okay, so the official name for this framework is Multi-Agent Evolve, or MAE for short. And the core idea is pretty clever. You create a little internal team of AI agents that all start from the same place and then learn and grow together. So let's meet the team. First up, you've got the proposer. You can think of this one as the creative, curious part of the team. Its entire job is to invent new, interesting, and genuinely difficult questions. It's not just pulling trivia. It's actively trying to push the boundaries and find the weak spots that the AI needs to work on to get smarter. Next in the lineup is the solver. This is pretty straightforward. If the proposer asks the tough questions, the solver has to come up with the answers. This is where the AI's actual skills get put to the test. Its reasoning, its math, all of its knowledge is on the line, trying to find the best possible solution. And last, but honestly maybe the most important agent on the team, the judge. This one is the critic, the tough but fair teacher. It looks at the question the proposer came up with and asks, is this a good question? Then it looks at the solver's answer and decides, is this actually correct? Is the logic sound? The judge's feedback is what powers this entire learning process. And this is how it all fits together. It's a non-stop loop. The proposer asks the question, the solver gives an answer, and the judge evaluates both of them. Then, based on that feedback, all three agents get a little bit better. The proposer learns to ask smarter questions, the solver gets better at answering them, and the judge becomes an even sharper critic. They literally co-evolve, getting smarter together with every single cycle. So it all sounds amazing on paper, right? But that brings us to the most important question of all. Does this whole internal feedback system actually make the AI perform better on real-world tests? Well, the researchers put it to the test to find out. And there it is. That's the headline number. After running this whole process, the AI model improved its performance by an average of 4.54% across a bunch of different tests. Now, I know what you might be thinking. 4.5% doesn't sound like that much. But in the world of AI, getting a performance boost that big across the board is a really, really big deal. It's a significant leap forward. And check this out. Those improvements weren't just in one specific skill. We're seeing gains in a whole range of tough areas, like general reasoning, math problems, and complex question and answer scenarios. This shows that the AI isn't just learning a narrow trick. Its general problem-solving abilities are getting a real upgrade. This really puts the innovation in perspective. The old way of doing things depends completely on huge human-made datasets and some kind of external feedback. But with MAE, the system generates its own data and has its own internal feedback loop. It's like a completely self-contained, self-improving ecosystem. And hey, don't just take my word for it. The authors of the paper sum it up perfectly. They call MAA a scalable, data-efficient method. Scalable because it can just keep going without needing more and more human input. And data efficient because it's creating the exact lessons it needs to improve without any waste. That right there is the key. Okay, so let's zoom out and think about the big picture for a minute. That 4.54% improvement is fantastic, but the method they use to get there, well, that could have huge implications for the entire field of AI. So this is why it really matters. A system that can teach itself completely shatters that data bottleneck we talked about earlier. It means learning can scale up in a way we haven't seen before. It could lead to AI that's way more powerful and independent, and it could seriously accelerate the pace of progress for everyone. And that really just leaves us with one final fascinating question to chew on. What happens when an AI's best teacher is itself?